Welcome to Chapter 6 of the Shapley Values series. In this chapter, we will walk through an example of how Shapley values are calculated in cooperative game theory. Let's dive right in. So, Shapley values express the fair marginal payout for the contribution of a player to the coalition in a game. Let's see how these Shapley values are calculated in cooperative game theory. Let's imagine our game is a hackathon. Players have to team up in groups of 3 to be eligible for the prizes. These 3 players team up to compete in the hackathon. Let's track the possible payout structure here. Let's imagine if the 3 players didn't compete in the hackathon, denoted as the coalition C sub 0, they would win $0. If the 3 work together, denoted as C sub 1, 2, 3, they receive a prize of $20,000. Although the hackathon requires a team size of 3 players, imagine that if player 1, C sub 1, or 2, C sub 0 competed individually, they would win a prize of $10,000 each. If player 3 were allowed to compete by themselves, C sub 3, they would receive a prize of $7,500. If players 1 and 2 teamed up, C sub 1, 2, they would receive a prize of $17,500. And if players 1 and 3, C sub 1, 3, all players 2 and 3 were allowed to team up, C sub 2, 3, they would receive a prize of $15,000 respectively. It's clear that in reality, having such payout information would require us to travel back in time many times and repeat the hackathon with different teams. In statistical terms, we are confronted with counterfactual situations for which we would require an actual causal model to identify the payout structure. Let's ignore this for now and pretend we knew about the actual payout structure for different coalitions. So, assuming a team size of 3 players is mandatory, let's see how to fairly divide the payout of $20,000 between the players by calculating their Shapley values given this payout structure. As we discussed earlier, the Shapley values represent the marginal contribution that a player brings to the coalition. So let's calculate for player 1 how much they contribute on average when joining an existing subcoalition. To do so, we note down all possible ways that player 1 can be added to an existing subcoalition. Player 1 can join an existing coalition of players 2 and 3, where player 2 joined the subcoalition first, C sub 2, 3, which results in the final coalition C sub 2, 3, 1. Together, all 3 players receive a payout of $20,000, and players 2 and 3 only would receive a payout of $15,000 if they were allowed to team up in teams of 2, which means player 1's contribution to that specific subcoalition is $5,000. The coalition between players 3 and 2 could also have formed with player 3 joining that coalition first, C sub 3, 2, and player 1 then joining the coalition. Consequently, player 1's contribution to this subcoalition is also $5,000. Next, we can start with a coalition of only player 2, C sub 2, have player 1 join next, and player 3 join last, C sub 2, 1, 3. This results in a marginal contribution of $7,500 for player 1 to this coalition. Note that we here consider C sub 12 instead of C sub 213 because player 3 is irrelevant for calculating player 1's contribution to the coalition of C sub 2. Analogously, all other contributions of player 1 to existing subcoalitions can be calculated. Note how the last two options represent player 1 joining the empty coalition C sub 0 with payout of $0. There are two ways of that happening, as a final coalition needs to consist of 3 players, and players 2 and 3 can join in different order, C sub 123 and C sub 132. Finally, to calculate the Shapley value for player 1, all the marginal contributions to the possible subcoalitions need to be summed up and divided by the number of possible subcoalitions that player 1 can join, here 6. This results in a Shapley value that is a fair payout of $7,500 for player 1. In the same way, the Shapley values for player 2 and player 3 can be calculated. These three values represent the Shapley values, that is, fair payouts based on the marginal contributions for all players. Note how the sum of the three Shapley values adds up exactly to the overall payout of $20,000. Going back to our formula for explainability models, Shapley values provide exactly these values that, if added up, provide the exact forecast or the exact payout. Mathematically, the Shapley values can be expressed as such. Again, don't panic. This formula simply expresses what we have seen just then. The Shapley value phi sub I for player I is the sum over all possible subcoalitions S not containing player I, where we sum the marginal contribution, that is, the difference between the payouts for when a player I is added to the coalition and when player I is not part of the coalition. This marginal contribution exactly corresponds to this column in our example, and this column expresses the possible subcoalitions S not including player I. For example, C sub 13 and C sub 1 when player I is 2. This part of the formula is just assigning each marginal contribution a weight, where the weight just corresponds to the number of possible ways a certain subcoalition S can be formed from the number of available players N. In our example, a subcoalition consisting of players 1 and 3 and therefore of cardinality S of 2 can be formed in two different ways, that is, by player 1 joining first in C sub 13 and by player 3 joining first in C sub 31. So the $5,000 marginal contribution of a coalition consisting of players 1 and 3 should receive a weight of 2 divided by 6, as there are in total 6 subcoalitions that can be formed from the n equals 3 players. We have now seen how Shapley values are used to calculate the fair payout for players that are part of a coalition in cooperative game theory.